This project is Residential Solar Utilization in California by Holden Green in association with the University of San Francisco Geospatial Lab. A crucial factor in understanding the growth of any renewable resource is an accurate estimate of the availability and rate of consumption. In the case of solar, the resource is incoming solar radiation, and the metric for consumption is how much energy is captured for use. California has experienced tremendous growth in residential solar capacity over the last decade. This analysis seeks to understand where this growth is occurring and whether areas that receive the most solar radiation potential have correspondingly high residential solar capacities. To answer this question, a new metric referred to as solar utilization was developed to understand what areas in California are successfully developing residential solar capacity relative to overall solar potential. This basically equates to an understanding of how much solar we have at our disposal versus how we are using it. We can then create a map showing where this relationship differs in California. Populated areas were selected because the focus of this analysis is on residential solar. Incorporating solar radiation estimates outside of populated areas would provide a distorted view of the potential for capture. This area, shown here in orange, represents the extent of the study area for this analysis. Solar capacity represents the sum total of all solar projects within a county. This represents how much energy we are collecting from the sun by county in California. As you can see, some of the highest capacity counties are located in the southern regions of the state. This information was sourced from the California state government and contains all residential solar projects connected to California's grid. This map shows the potential solar energy available to populated areas in terms of how much radiation is received per square meter each year. Here again, you can see that the highest potential areas are located in the southern portions of California, as shown by the dark orange and red coloration. The data was calculated using the Esri tool Area Solar Radiation and is based on a statewide digital elevation model. This slide shows the data from the previous map aggregated by county. It was calculated using the zonal statistics tool in ArcPro. We see here the confirmation of what was suspected in the previous slide, that residential solar potential is greatest in the southern counties. This conversion provides a common unit that we can then use to interact with the capacity data we've generated earlier in the analysis. Now that the two measures are in a similar format, we can apply the ratio with little manipulation of the data. To understand how much of the available solar each county is using, we divide solar capacity by potential. This simple calculation provides us with the ratio that we have termed solar utilization. The result is this map, which shows solar utilization by county in California. Gray areas represent counties with no capacity data, and as such, no utilization value could be calculated. High utilization counties are seen here as dark green. They indicate counties where the installed residential solar capacity represents a relatively high proportion of the incoming solar potential, meaning that they use more of the solar energy that is available to them than other counties. This does not mean that they are using more overall, only that they are using what they have. To understand how this trend carries regionally instead of by county, we employed a kernel density map as shown in the next slide. The hotspots shown here indicate areas that have high solar utilization relative to other areas in California. We can clearly see that the efforts in the Bay Area to promote growth in solar have largely been successful despite not being the most solar-rich region of California. Other surprising findings are the low utilization observed in San Diego County area. This could potentially indicate that there is additional potential for growth in residential solar and could suggest the need to improve incentives. These results clearly show that the greatest potential for growth in residential solar does not necessarily correspond to the location with the highest yearly solar potential. Also, despite significant growth in California residential solar capacity, there is still significant potential for future growth in areas outside of large cities, especially in southern counties like San Diego and Los Angeles. Future research could integrate more information into the model, such as the total demand for energy in existing utility-scale solar projects, to better understand the supply and demand for residential solar. Solar utilization provides an innovative and useful metric for planning and development strategies and could be useful in both private and public sector analysis. More research is needed to standardize this methodology so that the results can be compared across different scales and locations. Thank you for taking the time to listen to this presentation, and I would also like to thank the USF Geospatial Analysis Lab for their support in the development of this project.